test is if we all actually sit in our appropriately assigned seats, because the sound is tied to which seat we're in. So I think we're all good, right? Yes, we match the pictures, so we're in a good place. I appreciate you're all staying through the end of these 2 days. It's really quite a wonderful exercise to think about the breadth of research that happens here and the application of it. And my name is Bobby Stempley, and for my day job, I run the security work here at the Software Engineering Institute. And for this afternoon, I have the privilege of guiding us through a conversation about one of the other major changes we've seen in this software engineering landscape, and that is speed. Right, we've talked a lot over the last 2 days about growing the agility of the Defense Department and growing the agility of organizations by delivering more capability more quickly, thinking about how things have to change. We've also talked a lot over the last decade about how scale changes everything. And the sort of premise for this discussion is that speed changes everything as well. And to talk about when that can be real, what the kinds of decisions you need to think about differently because you can do things faster might be, where that gets us in trouble. I've got a phenomenal panel here of individuals, and I want to give them the opportunity to introduce themselves briefly here as well. Charlie, you want to give us a chance to start?
So I'm Charlie Holland. I'm the Chief Scientist of the Software Solutions Division currently. And in my prior life, I spent about 30 years running research programs for various parts of the Department of Defense.
Great. John.
Hi, I'm Jonathan Chu. I'm currently a site reliability manager over at Google on the cloud machine learning services, or some subset. A disclaimer, I'm speaking as myself. I'm not speaking on behalf of Google. Any opinions are mine, That said,
based on years of experience.
Yes, based on years of experience. Prior to that, I'm actually an alumni of the Emerging Technology Center here at the Software Engineering Institute, and I spent, up until recently, the bulk of my career supporting DoD mission, robotics, unmanned ground systems, counter-IED mission, and those sorts of activities.
Great. Michael.
Hi, my name is Michael Hilton. I'm starting my second year as a teaching professor here in ISR, not that type of ISR, the Institute for Software Research here at CMU. And but before I did my PhD on developer practices, mostly continuous integration. But before that, I worked for 9 years for Spay War System Center as a software engineer out in San Diego.
So thank you. You can tell we've got a lot of practical experience. I know these individuals, and they're pragmatists as well. So I think that's really really important. But also folks with experience really pushing the envelope, and I think that's also important for us as we go through this discussion. Certainly want to open the opportunity for engagement with the audience. We'll spend a little bit of time talking, and then as folks have questions as well, I think that's good. For me, one of the things that this idea of speed has really caused me to reframe is the idea of risk and how long or how much something might be at risk if I can change it in a more rapid manner. I had an experience being an accrediting official, so making a risk decision for the Defense Department. And one of the things we always considered is how long would something sit in this less than pristine state in the environment. And I think what a wonderful thing it could have been 10 years ago if I could have thought about having a new version out tomorrow, right? If I was talking about hours or minutes or days in that context. I want to offer the question to everybody on the panel. What does this idea of rapid velocity production cause you to rethink in your experience? Anyone want to take that first?
I mean, I think especially if you look at like continuous integration, right? We have this concept where a lot of people integrate automatic rollbacks, right? So even if you ship something and there's a problem, it will automatically roll back to the last known good version, right? And so in some places you can roll back faster than it even takes a human to realize that there was even a problem, right? And this is a radically different shift. And I was talking, I was actually yesterday giving a lecture on kind of the difference between modern code inspection and kind of more traditional, code inspection, the heavyweight like Fagan inspections versus modern code review. And I think one of the big factors that's driven the change is, it used to be once that code went into the lunar module, it's not changing, right? But versus now, if you have automatic rollback, well, if you get it wrong, it rolls back to something that works, and then we figure out what does work, right? And so I think this has really radically changed how people interact with their systems and how people think about the risk associated with getting something wrong. Maybe people play it a little too fast and loose sometimes, and I'm not necessarily saying this is 100% good always, but I do think it's been a drastic paradigm shift for most engineers.
Yeah, I've seen a lot with respect to that, the automatic rollbacks and automatic pushes and rollouts. What I've seen is you can put things out into production, and with these large-scale systems, you roll them out in small sections. You don't push it all entirely out to the fleet at once. You put it in small bits and pieces, and you might put it to 1% of your fleet, to 5, 10, 20%. If you see a problem along the way at these kind of inflection points, you roll back automatically. And so the 1% is obviously not going to show you the load, but you'll see if there's anything obvious that breaks. When you get to 10, 50%, these things start to really materialize really quickly at very large scale. And so it's not just rapid. When you have these other dimensions coming into play, not just the speed, but if you have a globally distributed system with a lot of users, that speed plus volume gets you a lot of information, which the automated systems can help you process and automatically triage.
I want to sort of explore this idea of what you need to look for in a minute.
So when I think about the Department of Defense, I think a lot about safety critical and sort of critical mission systems. And it is the case that when we think about electronic warfare, the department does operate in situations where we change software sometimes on a daily basis, because if we go out and we fight with the same parameters that we had on our radars that we had yesterday, we know we won't survive. So there is some areas where we have been for a long time operating with some pretty rapid updates. But for the most part, I think about safety critical systems, embedded systems, and certainly we want to be as fast as we can at delivering and updating software. And our belief is kind of that the more that we can have formal models that we can reason about changes, we can actually speed up the delivery. But it's never going to be as fast as people might want it to be, because people's lives are at stake.
Yeah, I think that's absolutely right. Understanding the situation where each of these capabilities might be useful, but this idea of formal models so that you can reason about the outcome really intersects interestingly with the idea of monitoring the rollout and sort of understanding what the outcome might be as we come along. Do you have any insight on the kinds of things you might need to think about in order to more effectively do that reasoning and see how well real life matches that model?
So some of the things that, try not to say what I'm not allowed to say. Some of the things we look at are internal health of systems, and we build a lot of things based on what we call service level indicators. And these indicators are these metrics, and they're defined with specific budgets. And this feeds directly into how you can release and how fast you can release. And that's part why I'm bringing this up. But these indicators feed into the objectives that you're trying to emit, and you can view them at multiple different tiers. For internal to your service, whether they're hitting the I/O metrics that you're expecting, whether they're hitting the bandwidth, whether they're hitting the things you expect of your system. You look at the control surface around your service, whether external people who are engaging with it, whether it's other users within your system or other in a system of systems. And then we also look at what the customer sees. If the customer sees an impact, and all of these different indicators impact what we would say is good, right? And so you monitor it at these multiple levels, but it's not good in a black or white sense. And coming back to that budget idea, we may dictate that it only needs, because of a cost model, 1 9, 2 9s, 3 9s, 3.5 9s, because the amount of money that you'll spend to get that extra 9 is disproportionate to the impact of that particular outage in some scenarios. Obviously, safety critical has a different thing. But the way we look at it is more in the N+2 style. We're going to have 2 more and do a resilient system versus that this component can't fail. And when you measure across all of the different components, you measure it and you measure it against your budgets to say, hey, if I'm above 4 nines and my budget's only 3 nines, hey, guess what? I can maybe try some things. See if it moves the needle down, because I know I'm maintaining the reliability that I expect, that my other users expect, that my customers expect. And this is a technique to control the pace of your rollouts. It's not just about moving fast and breaking things, but it's saying, hey, look, no, I have a controlled reason. And if you dip below that point, you can say, okay, now we've exceeded our threshold. We need to respond and we need to do something about it, and you can respond accordingly to bring that back up. It may be just wait. Wall time helps bring average numbers up, but this is an approach to how you look at your systems and from those different metrics, internal, external control surface, and ultimately to the end user, and how you deploy them out. And each one of those gives us different signal and different information on how we would release products.
It's interesting you use the word budget there, right? Because that implies you've thought ahead of time about how much of, whether it be developer time or CPU resource or some other activity you're allocating to this. And when you think about safety critical, there's an awful lot of that thinking about how much I can budget to any particular thing. It's how do you think about that?
Some are driven by product, customer expectations, right? In the Google example, how do you check if your computer's internet's working? You go to google.com. That has to have some very high number of 9 reliability. Other services, you can get away with not having that many 9s from the external surface. And you have to measure it different. 101% errors looks different, right, to all your customers. If everyone's receiving 1% error failure rate, that looks different than one customer that's out, one of your 100 customers that's out entirely. And so you think about all the dimensions upon which you can measure, you sensor your system as best as you can, and then you roll those up into these aggregates so that you can assess whether that's effective. And most of the time, you try to drive these numbers to something that's manageable, like in terms of cost, right? The expect to that first, one of the first comments I made about the cost to getting 5 or 4 or 5, maybe even 6 nines is a lot. It's very, very high. But getting to 2 may not be. And if you compose the right number of systems that are 2, 3, 4 nines together, you may have an overall system that hits your 5-9 availability with some known, I don't call them failure conditions, but some known conditions. So that's a way to look at your system from a holistic perspective and allow you to release in sub-components, sub-parts, and get things moving out faster, because it's not the, hey, I got to change out the codes, I'm pulling this and plugging in a new component. So.
Interesting. So, Michael, one of the questions I have is, as you think about how to help people really absorb what this means to them as they're saying, I'm going to change the world in a particular way. Is there some set of sort of resilience concepts that you're reinforcing with your students?
I think one of the biggest concepts that is kind of been paradigm shifting for students in general is this concept of, for many people, the world is so interconnected now that you don't have a pure test sandbox and then production environment, right? And so, there's specific techniques that you can kind of, at low-level mechanical techniques you can do to help improve the availability of your services, right? But I think the biggest kind of massive paradigm shift for students is when you put them in a situation where everything they do is live, and you have to, this really kind of changes your paradigm versus, well, I'm going to do something in this sandboxed test environment, and then once it runs past some threshold of quality, then we're going to move it to production, right? versus for many people now, many systems, there is no, Netflix famously doesn't have a sandbox test Netflix and then the, real Netflix. They just have Netflix, and, this is why they do Chaos Monkey and all this kind of stuff. And so I think this whole concept, I completely agree with what Sean's saying about this whole thing with having, composing these multiple systems together. But in this world, everything is so complex, you just can't test it in a, on your machine and then say, well, that's good. I'm just going to now 5 p.m. on Friday, push it to the cloud and go home, right? Everything, it only works if it works in production in this complex world, right? And this creates a much different expectation on the developer as far as how they think about what their changes are. There's essentially no safety net, right? Or you have these safety nets built in through rollback and checkpoint and stuff like that. So it's a pretty massive paradigm shift to think I'm making this code, and this code is going to go live in this whole complex interconnected system, and it really drives motivation for monitoring, for having resilient systems, for having kind of all these things really get driven as a motivation of, well, this code's going to have to go out there into the world and see how it exists in the world, and that's the only real way to evaluate it. And I think that paradigm shift of, well, I can just test it locally, to I'm going to have to do my best, create, drive unit tests, right? Do localized testing, and then it's going to go out in the world, and we're going to have to watch it and maintain it and take care of it. This is a massive paradigm shift. I think it's really changed how people view their development process, the concept of taking an idea and pushing it out into the world.
I'm struck by the talk before us, which was how complicated V&V is, right? Because that's almost orthogonal to some extent to the concept you're talking about. It's complicated because the world is so complicated, and you may not be able to get to perfect, so what is good enough in that? I'm sorry, John.
No, it's okay. One of the things I wanted to build on top of that with that paradigm shift is also what the expectations of production looks like. Devs develop live, and so it's their responsibility as well. There's not a system administrator concept in some organizations. It's not, hey, I'm throwing it over a wall and then the operator will operate the system. It's not an appliance. It's not a toaster that, or a microwave. There is a shared responsibility for those who basically do frontline support on it, and they have their techniques to engage and assess the production health of the system. But it goes back, it gets escalated back to the developers. The developers ultimately own the feature sets. They pushed something out, it broke, production saw it, said, I can't deal with it. Hey, guess what, developer? You're now getting the page, right? You're on the hook. You pushed out the feature, I didn't. I'm just the frontline help desk support, if you will. How does that look, and how that changes how people think about development is huge. When you know that it's not going over a wall, and that you as a developer will be woken up in the middle of the night because you broke something. You, on Friday afternoon, decided to push something to the cloud, which you will get a lot of nasty emails about if you do. But yeah, that thought process changes, and that ownership of it is that it's owned all the way through to the end user. And it changes the view of some of these more mature and these more fast-pushing systems, rather than, hey, it's big, it's monolithic, I threw it over the wall, and I have an ops team that handles it. One thing I'll talk about at Google, because it's in the site reliability book, engineering book, is that ops load is a failure mode for site reliability engineers. If we get stuck in doing ops work, we throw the pager back. That is our ultimate escalation. We are not going to be on the hook for this anymore. This is now yours again. Go fix it. And then when you're ready, when you get the reliability numbers back up to where we expect, we can be your frontline support. It changes how people think about it. Instead of saying, hey, look, no, we want to throw it over the wall, right? Own the pager. No. We will take the pager from you when it's in the position that we can take the pager. We will help you maintain the production health. It's your service.
So Charlie, what does that look like in your mind in sort of the defense?
So I was going to think about two different applications. One, I'm quite excited about the work that's being proposed to be done at Kessel Run, which I kind of view as kind of programming in the small, where the Air Force is trying to do, I would say, operations research in a better way. How do I schedule aircraft? How do I do tanker airlift? And I think it's really great that the Air Force is pushing technology people out with operators. And you're trying to write code that's going to be close to optimal, but the result is, hey, if it doesn't quite work, then I can always launch another tanker or I can abort the mission, and there is no real failure, okay, in the sense of catastrophic failure. But that's different than if I've got an F-35 or some aircraft and some piece of microelectronics fails and now the system has to reboot, and I haven't actually thought about how the system is going to reboot. So the testing and understanding failure modes really consumes and lengthens out the development mode for a lot of systems. And you really want to go through all of that because there is no recovery in place, okay? I mean, during the actual mission. So diversity of things, I think, for the Department of Defense. And so I don't think there's one size that fits all. But I do see that the DoD should be pushing to be as rapid as possible in the domains that it should be. And rather than relying upon monolithic contractors, trying to get people closer to the developers is probably a good thing.
Interesting. I think for me, this idea of complexity is almost the antithesis to the idea of speed, right? Because the more complex the environment is, the more difficult it becomes to predict, in so many instances, what it will do. And I look for as much confidence as possible in predictability, right? When I turn the light switch on, I want the lights to come on. When the F-35 takes off, you want it to, you want the software to be, to function in a way that's predictable. I read public transit in Virginia a fair amount, and I can't tell you how many times they have to reboot the bus because it's ended up in a state, and the bus driver will say, I'm getting a warning number I don't recognize, and my manual says, turn the bus off, sit there for a minute, and turn it back on. And I think that's, that's not an acceptable answer. How do we think about this idea of testing and complexity in this space?
I guess a side question is, I'll challenge on some set of systems, I'm talking on a different domain.
Yep.
Why is it not that you can reboot a bus?
It certainly works, right?
Right?
I'm a minute later. It's not
Right,
that big a deal.
Right, and if you have how many minutes of outage a year on that bus line, how many nines are you?
Yeah.
Back to that point, and I don't want to beat up, but it's inconvenient at the time, but at the overall metric of reliability, and when you do a meta-analysis about the risk associated with it, obviously if the F-35 is rebooting in the air, we have a problem,
Right.
but certain systems, and it may be more on the risk model of, can we reboot it? Is that okay? Is 30 seconds of downtime okay? And maybe the effort's better spent, rather than finding all the possible failure modes, saying, hey, get boot time down to 3 seconds, right? I can spend engineering time to get boot time down so that I know when I reboot it, it's up and running and I'm good, rather than, okay, what are the exponential possibilities, the exploding possible cases of every test? Okay, no, reboot it and go. I recall
Keep going.
a colleague of mine that worked at TiVo, and he said one of the things, anytime they got an error code that they didn't quite expect, they just reboot the box, because you're sitting there watching TV.
Right.
You don't want to figure out error codes or why. You're just going to be annoyed. You tilt your head sideways and say, oh, okay, that sucks. And then a minute or two later, you're watching TV again, and you basically forgot about it, as long as it doesn't do it all the time.
And you get the happy TiVo face.
Yeah, you get the
So
happy
that's-
TiVo face, you go get a drink, some popcorn, and you start again.
That's interesting.
So a lot of, I think, what comes down to, the complexity exists, right? We can't just wish it away, right? So then the question becomes, how do we deal with the complexity? Which is essentially the core question of all programming, is you're trying to reduce complexity to some manageable level so that you can get some task done, right? And I think what we see a lot of people doing is, instead of trying to manage or mitigate the complexity entirely, because that becomes a fool's errand, you lean in and you kind of embrace the complexity, right? And this is what Netflix does with Chaos Monkey, right? The failure rate wasn't high enough to kill the boxes enough to make all the engineers worry about all the failure cases enough. So they introduced failures into the system to raise them to a level to where all the engineers would take this seriously and work on it, right? And so you can try to create the system that will handle all of the contingencies and all the problems from the very beginning. And there's definitely cases where the risk is such that you have to do this, right? Especially, going to the classic, airplane example. But in some senses, maybe it's just a matter of we're just going to normalize failure, and we're just going to make failure a reasonable outcome, and we're going to make it something that we can live with and deal with it in a way that is acceptable. And that's going to be some of the way that we mitigate complexity, is by just embracing the fact that complexity happens. We can't plan for everything. We're just going to monitor it, and if we see a certain error coming up, then we'll devise a plan then, and not kind of take the burden off of ourselves of having to have planned out everything perfectly in advance and handle all possible scenarios before we start, right? Because this is one of the key things that slows us down, is having to plan for every possible contingency. And if you give yourself permission to say, well, we're going to fail gracefully, we're going to fail quickly, and we're going to fail in a way that we can recover, then we can just press forward, put something out into the world that has value to, whether it be the warfighter, support, the customer, however you want to think about it, and say, well, there's going to be cases where it's going to fail, and we're going to embrace that, we're going to be okay with that, and we're going to plan for that, and we're not going to just, give them some cryptic error message that they have to look up, and we're going to move forward. And maybe there's many situations where that actually makes more sense than trying to plan for every possible failure mode up front.
What do you think, Charlie?
Well, I'm always thinking about sort of hard problems for the Department of Defense, and I worry that sometimes, rather than trying to discover what is the real solution to the problem we want to do, that we just try to solve the problem we know how to solve, and sometimes that turns out not to be that useful. So I do worry about, I'm just kind of a different kind of guy here, I just kind of worry that sometimes the attempt to be speedy at the expense of thoughtfulness can get you into a lot of trouble, or cause you to deliver products that really aren't that worthwhile.
Yeah, so what's that balance between thoughtful but timely? Because if we harken back to how we opened these 2 days, it was the sort of 4 challenges that the Defense Department has with software: timely, affordable, trustworthy, and capable. Timely is really important in mission context.
As long as there's some capability.
Well, I sort of presume that if I have no capability, I haven't been timely, right? But how do we think about that sort of balance? Anybody have a thought?
I think it's for me, it comes back to the risk or the trade-off between your benefits and your risks. If developing this feature gives you a capability that you may not have had, and you think it may be worth it, go ahead, right? I mean, I do recall, especially in the late 2000s, developing counter ID systems. If you said you could do something that was counter ID, the department would buy it. Like, I'm being flippant, I apologize to those in the room, but it felt that way with pretty much anything you developed, especially if it was robotic and you say you were, keeping people out of harm's way. It was capability that wasn't available. And so there's obviously times where that is accepted. And what's the difference on that? I know money is probably one of the big ones, but why was that acceptable in certain arenas and domains, and I can ship something out in a JUONS, right, that has some capability, or instead of, hey, no, I have to go through all the proper milestones? I didn't have an answer. I know on the contractor side, I was like, okay, I have work and money's coming in. We're good.
I think that's thinking about the whole set of processes that, if we think
Right.
about how we do these things faster, you have to really rethink the processes that
Right.
go behind so many things.
And there's a spectrum there. It's a trade-off. It shouldn't be that on one end it's absolute, and then when you drop off of it, it's an R&D and it's its own thing. What's the incremental? Back to the speed of deployment to a patch. If it's a 70% solution, but I can get it yesterday, is that better than a 90% that takes me 2 years? What would you rather have? If I could turn that dial, how would I turn it? but the processes need to be in place to allow you to turn that dial. Someone needs to be able to turn it. In absence of that, you have either fully vetted, fully tested systems that don't show up, again, being a little flippant, and then, or R&D systems that demonstrate capability in a gymnasium or in an academic setting that will not be fielded.
I have something I'm going to say. I keep using the word paradigm shift, but I think it really is important to keep in mind that this is a radically different idea, right? So if the point is we're going to do everything the way we've always done it, but we're going to slap the DevOps label on it, and we're going to be fast and loose, but you still have, well, then if it fails, well, it fails, it's done, and the project is done, right? The point of doing this kind of incremental work is that you deliver something, but you learn from your failure and you keep improving it, right? It's not that it just is a failure and you stop, because that's not helpful. My brother-in-law used to be a Navy SEAL, and the first thing they would do when someone delivered a new piece of tech to them is they would just hold it at shoulder height and drop it on the deck, and if it broke, they would give it back and say, we're not even going to start looking at this, right? And he said it would surprise you the amount of times that people delivered something that wouldn't survive a drop from shoulder height. And this is a required, so you want to fail early, right? And you want to get this feedback. So how can we get the feedback and fail early? And I think, to me, this is one of the tensions of, getting it all right means you're not failing early. So when you fail, there's worse consequences to the failure as well. So if we can have the failures happen as quickly as possible, this is one of the things you learn in grad school, right? You want to fail as early as possible in your research because you've accepted the fact that there will be failure in research, right? We used to joke around and write on the board, failure is always an option when you're doing research. And so if you're in this mode, you want to fail early, but you want to learn from the failures. I think if we think of failure as the stopping point, then it's much different than if we think of failure as just the first lesson that we've learned along the path to success.
And on some of the larger systems, as they mature and get better, and with all the automation, failures are exciting. Like, you're amazed. You're like not even mad. You're impressed that it broke in that way. And you do detailed write-ups, and you're excited because there's a new engineering opportunity based on the failure. Because as it matured, you're like, oh, it's good, it's not gonna break, and then something spectacular happens. And it's amazing, and everyone's in awe, and everyone wants to see the write-ups and the postmortems, and it's really cool. But that's embracing that idea that things will break. They will always break. They do now, right? How do you get it so that you're thinking about this being acceptable in the right context?
So I do think these are all very interesting ideas. And they kind of are very appealing when you're thinking about the organic people who are actually doing the work. I think the challenge for the Department of Defense is if it's really going to have its contractor base do this, and its contractor base wants, periodic payments and everything else, is how do you really kind of get this rapid software development process properly implemented so that people get the right incentives and get rewarded in a manner that makes it fair to them and their shareholders, right? So, I mean,
But I think that incentive structure is really an important thing that needs to be thought about in the paradigm shift.
And we're hoping that the Defense Innovation Board will solve that for us.
I think they're having a public meeting right now. So
maybe by 5
they're
o'clock
announcing
today we'll know the
that.
answer.
Exactly. Exactly. I think I'm intrigued by this idea of, what happens if we could reboot in 3 seconds, right? In my experience when I worked for the Defense Department, I found the most innovative people were the 18-year-old Marines, right? They figured out how to do stuff that I didn't think was, it wasn't even a thing you thought was going to be possible. And I can see them saying, it'd be okay if it didn't work as long as you got it working again in a reasonably imperceptible amount of time. Right. So how do we think about that incentive structure causing us to come up with the paradigm shifting different ideas for things? Anybody have an idea? It's a tough question. It wasn't one I know we prepped for, so.
I know there's examples within Google, where when things have broken spectacularly, examples like interns with root in production for whatever reason, which I don't believe is the case anymore. But they get invited up on stage and basically congratulated, high-fived in front of the entire organization because it's amazing. Hey, how did you do that? Right? They said, hold my beverage, and they did something fantastic. And that the ability to allow people to do that is both how you innovate, right? You can think of really creative ways, and sometimes if you think about the penetration testing and the adversarial actions, you need to be thinking in that approach. You need to be allowing people to break your things. Exercises purely as blue team, is hard. You just get that blue team person to play on the red team for a little bit, and all of a sudden their brains are going and they're breaking things in every way that they never knew could happen, and then they go write it up as on the blue force. That sort of activity, maybe flipping and putting them in different positions, different seats, is a way to have them think about the problem that they've been attempting to solve for maybe decades in a different way, right? How would you break this rather than how would you prevent it from being broken? Well, now that you broke it, guess what you get to do? No good deed goes unpunished.
Right.
You have to go fix it now.
So Michael, I know you work with this idea of what does software engineering look like for the startup community. Are there lessons that we could learn from that?
Well, I was just actually thinking that was what was going through my mind when he was talking about this, and I think it's really interesting if you look at the lots of startups started out as something wildly different than what we know them as today. Twitter started out as a podcasting application, right? Flickr started out as a multiplayer online game, right? There's countless of these startups that started out as they had some idea, they thought this was a good idea, they put it out in the market, and it was actually a horrible idea. But some set of users were doing some interesting thing with it, not how the creators intended it to be used, but it was interesting and creative and exciting, and so they leaned in on that idea and threw away the stuff that wasn't working, and they went with that, and now they've created something amazing, right? And so this is, to me, yet another reason why I completely agree that this is why we need to get things out there, even in an unfinished state, because maybe it's not about the failure mode, maybe it's about some, young Marine or sailor taking your software and saying, you know what, it doesn't work for me for what you tell me it works for. But if I put in, this and this, I can use your visualization package to figure out these things that no one could answer this question before, right? I mean, this is actually an example we really worked with, that we had some software that did something and it was just an experimental thing. We sent it out to Fifth Fleet, and suddenly we found out there was this one visualization package part of it that they were using this mapping part, and they could take different data from different things, and they could use the mapping software and get some information that they couldn't get any other way. And so they were all using it just for this one exclusive mapping thing. So we threw away all the rest, and we dove in on that and created a usable tool for them, right? And so part of this is this getting it out there and getting the feedback is not as much about some of it's the what we call traditional failure of, there's an edge case of a bug that causes the system to reboot, but some of it's just having this conversation with your customers and realizing that oftentimes what you think they need is not necessarily what they actually need. Right. But by giving them something and letting them take it and run with it and play with it and being open to the fact that they might use it in fun and interesting and new ways can create a whole new world of opportunities. And I think it's very, very rare to see a startup that just has an idea, goes out and executes the idea, and is successful based on their original premise of what they thought everyone wanted, right? You get something, you get it out there, you learn from your customers, you figure out what's working, what's not working, and then you pivot. It's this concept of pivoting, right? If you're all familiar with the startup lingo, pivoting is the big thing. So you do something and you pivot, then you do something and you pivot, and you do something and you pivot. And I think there's value even in the DoD of creating some software and then pivoting based on what the needs of the warfighter are, based on what the needs of your customers are. And this absolutely brings up a huge challenge in most DoD contracts are not written in a way where it's easy to pivot to say, oh, well, the warfighter likes this one part of the thing, let's drill in on that and throw away the rest of what you said you were going to do, right? As a contractor, this is not really what our system supports. And so there's real challenges there that I don't mean to diminish or make those sound like those are unimportant. But I think being able to get something out there and let people, and pivoting off of the feedback you're getting from the actual, real, honest users of the system is absolutely invaluable.
Yeah, doubling down on what is successful in that regard. I want to sort of do one more round of questions with us and then raise the lights a little bit and let the audience ask some questions if they have. I'm struck by how as we move into this world where software's writing software, right, where things are non-deterministic in this kind of space, and so we're now evaluating abstractions in order to make security decisions and feature decisions and other pieces. How does that change our thinking in terms of this paradigm of speed? Does it make it better? Does it make it worse? It's never a good thing when the moderator asks a question that makes the panel stop for a few minutes and think. So, but I think it's, for me, it's back to that. We have to get to abstractions because the environment is so complex. And so we're reasoning based on those abstractions. And then we've got to find ways to make the time period between that abstraction and what really happens, and noticing if what really happens is what we expected, as short as possible, right? That, to me, I think feels like the thing we've got to figure out how to do.
I mean, I think that, generally speaking, programming is about using abstractions to manage complexity, right? And we've gotten very good at this in terms of using abstractions to manage the complexity of registers and memory management and moving numbers around on a CPU. And we can do that, and I can teach students how to program, and they can program very efficiently with languages that use high level of abstraction over the physicalness of a computer, right? And what's really going on there. And we've kind of mastered that stack. I think what you're talking about is even higher level, mastering even higher levels of complexity with new abstractions. And I think this is a huge challenge, and I don't think we as an industry have nailed down exactly what the abstractions are, how we can teach and share those abstractions in a way that programmers can manage this even greater levels of complexity yet. And I think this is a huge open question and a huge topic that people are starting to think about and being concerned with, but I honestly think it's not something we have a ton of answers on yet.
Yeah.
I guess I would say that the spiral work that we heard earlier today is an example where if you can specify your algorithmic space at a formal level, at a formal enough methodology, you can then reason over the parameter space and automatically derive very efficient algorithms that will run optimally on a range of different microprocessor architectures. That's to me, very important work. You know, it's really good in the signal processing domain, and so that's one example.
Of a practical application.
A practical
of this
application.
in this kind of space.
I was just thinking about with the abstractions. The other thing is that to what level of certainty do you want your result to be? Within what bounds? Are you accepting of looser answers or a looser specification language? I'll point at Matt in the audience. He always said that he had his human compiler. He'd go tell us something to do, and we'd go crank on a keyboard and go make it happen, right? So that does exist. There are abstractions. I think they're just not as formal. Do you need a formal model for everything? There are times and places for all of these things. But back to that spectrum of capability, can I get away with something looser? And if I can, what does that afford me? Can I move faster? What additional capability beyond just speed do I get out of turning that knob just down or up just a little bit?
Yeah, interesting. I want to give the audience a chance for questions as well. And now I can see Tina. I think there's a question over here.
One in the back.
Over
there.
It's a really dark audience out there, I tell you.
I think the first question's in the back there.
Yeah. So cybersecurity is usually considered a global property of a system. And since you're having systems change rapidly How do you manage knowing what your cybersecurity posture is?
I'll start, I guess, and
Can't talk about my organization.
yeah. So I think for me, the reality of understanding not just what your cybersecurity posture is, but how it's changing, is tied to understanding what you're monitoring and understanding how what the conditions it went out under might be. I mean, I think the complexity in the environment is so great at this moment that it's hard to really grasp what your cybersecurity posture is in the first place. And so we've already abstracted that metric a little bit and are going to continue to do that over time. I actually think if you think about the strongest asset in the hands of the defenders, it is dynamicism, right? The ability to remove the foothold of the adversary, and so the ability to make those changes so that adversaries don't have long-term footholds is, I think, an untapped opportunity.
I think this again pushes security on everyone now. You can't just have the security engineer that does security. Everyone has to be conscious of it and cognizant of it. And I think as academia, I think this is one thing that we've been slow in responding to. I think we need to get better at is teaching everyone principles of security. Like security now is something that needs to be taught to everyone, not just to, you go get it as a master's and you're the security engineer for your company. Everyone needs to be aware of security principles now.
And if we increase quality, that helps to some extent, right?
Yes.
I mean, it doesn't help with everything, but it helps with some of the foundations.
I think also with these large scale like systems of systems, if you kind of dynamicism and stuff, and if you're willing to take some minor, I'll say DOSing yourself for a little bit, is it the end of the world if you shut yourself out for a small portion of the time because you're moving so fast so you can reboot yourself or you can get that nature, you say, okay, it's okay. And along with that, you say, I don't trust anyone, even my own stuff, because the insider threat is still there, or the near side, right? Like that still exists. So how can I put myself in a position that things will reboot or shut off, binaries will restart every so often, just because I don't want to let anyone have a foothold. This is kind of the part of two-factor, right? So you have something, but if you make your user two-factor in every hour, it stinks as a user, but it's pretty good from that perspective.
Other questions?
All right.
I have one comment, I guess, as it relates to security. What kind of keeps me up at night is that I think the department isn't paying enough attention to thinking about the computing infrastructure it's going to have to live with in the future if it doesn't preserve a viable U.S. microelectronics industry. Because if you think your software is executing something, but in fact it's really going to be doing something different because you don't really know what the hardware is, there's going to be a big problem.
We have a question over here.
All right, so maybe I'm going to dig into this sort of fail-fast sort of commercial paradigm versus the defense paradigm specifically. So if you take a standard large commercial model for software production and deployment, typically that infrastructure is curated by that company largely. Now that's not entirely true, but you've got an OEM base or something out there that you're working with if you haven't personally curated it, which creates consistency in the deployment of that software to that hardware. In the DoD, we deal with all sorts of legacy embedded, proprietary, safety critical, life critical stuff. And it's not made by the same vendor, and many of those vendors are not OEMs to the person who's trying to integrate that with more, recent paradigms like cloud infrastructure. So the question is, do you see a future commercial market for that? In other words, do you see the commercial market gravitating toward being able to handle stuff they didn't make, they don't own, they don't have any licensing interface with directly, and yet have to literally make life, critical decisions on kind of, until the next contract comes around where they replace all that stuff, if that's even possible, right? So, and I know that's a loaded question, but it's worth, this is just to kind of contrast and explore where that's going.
I would say for commercial industry, are there the financial incentives there in place to invest in that market? Is it large enough, big enough to sustain an organization? And maybe this might be one of the smaller organizations where they can be more disruptive and do some of these things. And there are some big players that are, I'll say, not entrenched, but they know how to work with the government. They know how to work with the department, and that's kind of just the old relationship. It's there. Is there a financial incentive for, and with the new growing of developers and voicing their opinions about ethics within computing, especially in Silicon Valley and other places, can you get the incentive for them to buy into that? And I think that's where the kind of the delta is there's people who focus on the mission and they'll do what it takes to get that done, and there's others who are looking at shareholder value and how do I deliver that to basically my investors. And is the market big enough, right? If I go after retail, I know what I'm getting into to some level, and I know what the marketplace is. Government, I see it every, in the budget. I know how big it is, and I know my probability potentially of landing it and what slice of it might be mine. Is that worth it? And if it's not, they may not want to play. And I think that's unfortunate. But I don't know how to kind of, again, slide that scale such that you can give these incentives, right, for long-term value. Because it's a one-off contract's great, but the shareholders are looking for year over year and growth, which is hard to see.
So, Bob, may I re-ask your question in a slightly different way?
Sure.
If we think about industry in two ways, I guess for me, one is there's a set of individuals or companies in industry that have really locked in their tech stack. And they are super locked in their tech stack all the way down to the hardware, and it's a non-negotiable kind of activity and lets them innovate at a different level. But I think there's a range of industry that hasn't made that choice. And so for me, the question is, what are the lessons from that range of industry that the Defense Department might be able to learn? Is that, Michael, do you have any, I know you.
Well, I think one thing that, I'm not sure if this is exactly answering your question, but I think it is interesting to note that anybody that's tried to set up a smart home of the future setup will tell you that not everything is as rosy in industry as far as interoperability and playing together as it is in certain areas as well, right? And so there are certain limitations when you get to actual physical realities of sensors and hardware systems and cyber physical systems, that there's just more of a legacy lasts longer, right? So one of the advantages of the cloud is that legacy doesn't really last that long, because that machine's getting switched out for something new on some timetable of probably a year or two, and so there's not really this kind of burden of maintaining a legacy support for everything in the cloud, because it just rotates so quickly, right? And when you see situations where it's in people's cars or in their homes, things that don't rotate as quickly, a lot of this nimbleness and the agility of industry starts to kind of break down. And so I think being realistic about kind of what areas has industry been successful in and which areas have they not been successful in, I think is important, to not try to kind of have this feature envy of, well, we're stuck in this, we have all these sensors and we have these cyber physical systems and we wish we were behaving like Netflix. Well, Netflix has 0 cyber physical systems, right? So they don't have those constraints, and that's just the reality of the thing. And so you can't, so there's things that the DoD does that can very well look like Netflix and probably could be architected like Netflix, and you could learn a lot of lessons from Netflix, but there's a lot of things that are not Netflix, and you just can't expect, the software in my car that's 3 years old has a bunch of problems and a bunch of bugs and a bunch of interoperability issues already, right? And that's
Yeah,
so
but I find every time I take my car in for an oil change, I'm actually getting a software update.
you're getting a software update. I mean, they're trying to mitigate that, but it's just not the same as Netflix's roll it back, all this fast delivery stuff, right? And so you have to be realistic about what are the constraints you're operating under. And I think the argument from industry would be, well, you do this kind of microservices architecture, then you take your legacy pieces and you surround them with some translator code that will then kind of isolate that complexity from the rest of the system. That's the theory. In practice, sometimes theory and practice, there's a difference between theory and practice.
Actually, that was going to be my next question, so that's good. I mean, so yeah, I mean, I'll just say that this paradigm that you've been discussing comes up a lot in discussions I have every day. And what I'd like to do is get commercial folks to come in and answer that question as honestly as possible, because it allows our decision makers to see where the boundary is. And then there's ways that we can create technology, like we've been hearing about for the last 2 days, that can bridge the gap that we're just describing, right? So once you identify the problem, you can address the problem. And so microservices is one way to go. Abstraction is another way to go. Model-based methods are somewhere in between. And, I think there's a lot of opportunity in that space, which might end up creating a whole new commercial market, right? But it tends to be the investment that the government makes up front to take that super risky sort of IRAD path first, and then, a market emerges. Just thinking, anyway, I don't want to monopolize the mic.
So I want to ask about the word velocity. We've talked about time. We are always going to talk about dollars. But the distance between a cockpit working group and an actual field deployment of a capability is much more than a matter of time. And I think if we look at how Google's achieved velocity, they're not talking just about time. There's a collapsing of the intermediate steps. There's a trust. There's a new bridge there. So how do we learn from that and apply it in a much more complex setting and not only talk about time?
So how about we think about what are the things that need to be collapsed within that, right? And then who are the groups that we need to build trust between? We've spent a lot of time here talking about how to do that in the sort of DevOps world as a part of it. Do you have any sort of advice on what are the process steps that need to be collapsed that will help with that velocity? Because I think time is the proxy. It's the metric we use to say we were successful in doing that collapsing kind of activity. Any ideas?
I think it's a challenge to the previous questions, kind of what ends of the spectrum you're pushing towards. You have one where you've abstracted away everything else and you're a monolith. You own the whole stack. Even if your services aren't monolithic, your system is a monolith. You own the whole thing. Versus if you don't, you have to spend the communication time, the setting up the control surfaces, the APIs, all of those other surfaces, and each one of those interconnects is time. Collapsing it, I mean, it's the pendulum swinging back from modular to monolithic. You may need to own those steps. You buy a foundry because you want to have the supply chain, and you want the chip, and you want to go through those steps, so you trust it and you can move it through. And if not, you are then moving you're shifting the costs. The cost is going to be there somewhere, right? And I think it's just maybe the question's not about that, but where do you want to own, and what do you want to own? And where do you want to shift those costs? Because you may not be able to support a monolith, but you may be able to collapse certain areas because those are the ones that are taking the bulk of your time.
So from my perspective, to sort of take a gainer at one of the relationships that we could do better is the relationship of the security team with the developers and the operators as well, right? Because I think this idea that everybody has something to say relative to security, and security has an advisory role and a stake in the success of the product or the service as it comes along, I think is an important mechanism. And then the events, the tooling and automation and the production produces artifacts that security can use as well, that isn't sort of this separate overlay that happens on it. I think that's an important thing. I think the other thing from a management context that I know is small teams can do a lot. And really thinking about how big your team needs to be to accomplish this thing and making it that big and no bigger, I think is also an important sort of function. At least from my experience in that context, it's an important part too. We have one more question. That's good. I think that's
Hi.
all the time we have too.
So there's an old SEI technology some people may remember called Octave.
Mhm.
And Octave was a risk management approach that looked at some of the kinds of
forward,
risks we've been
forward,
talking about. Am I too loud?
No, is, not was.
Is, yes, is. It was developed decades ago. But its purpose is to help organizations understand
Mhm.
low probability, high impact risks, and to be able to take a systemic view of what should we do about, what are we willing to do, right? And that's, I see that being the piece in the DoD that we're not always willing to deal with, right? That is our F-35 world, right? If it falls out of the sky, the impact of that is enormous. Low probability, but high impact. So when I think about that kind of context, I don't know that I think automatically, Jonathan, of Google living in that world, right? I do think about nuclear power plants living in that world. I do think about the people that build my dad's pacemaker, medical devices in that world. I think about hospitals that have multiple systems, their radiology system and their pharmacies. You talk about a system of systems. They're right there. They're multiple first responder systems, 9/11 and all the things. So we have this set of things in industry that are actually more like DoD than Netflix and Google. No offense. But I never saw Octave take off. In those realms. I never really saw that take off as a really highly used thing. And so I guess my question is there something that's unifying across DoD and these other low probability, high risk things that is sort of this human aspect of, I don't want to deal with that. That's what it feels like to me sometimes is we'll make the broad statement about how this is very risky, but we won't figure out what is the risk point that is that low probability, high impact thing. And that's exactly what you guys were talking about earlier, about figure out how to reduce the complexity by looking at the piece that is the one that's going to, kick us in the butt instead of looking at everything else. Have we been able to, I don't see evidence that we've been able to kind of crack that thinking paradigm that will allow us to separate what can fail from what absolutely cannot fail without high impact.
I'll take a stab at that one. I think some of the approach that industry and the one that I'm currently in takes is much like the chaos monkey or these disaster tests is, no, you know what? We're going to make it fail. We will force it to fail. Like I will crash an F-35 equivalent. I will take down a data center. I will send out an email to people and say, we're going to take this down. What's going to happen? And respond. So it's a different revenue and material cost model, but without actual physical hardware. It looks entirely different when you say, hey, you know what? We're going to make it break. There's explicit exercises all the time to make it break, and you want it to break because when you find it, it's spectacular. You write it up and then you go fix it so it doesn't happen again. And this is what drives the innovation to make that monolith even more tightly integrated and stronger, and there's communication across all the different components so that when things do fail, you know exactly how the system's will respond. But it's all predicated on the fact that you broke it. You forced it to break. Like, why do we crash test a car, right? We want to know what happens when you slam it into a wall at 35 miles an hour. We're not doing entirely finite element analysis on it to say, this is what I think is going to happen. No, I smashed it into a wall to find that out. And I'll do it again and again and again until I find out how to do this better. What's the equivalent in the DoD that also fits within the cost constraints of, I'm not going to crash F-35s until I figure out how to do it right. Like, I'm not going to reboot system by system and say, oh, yep, there goes one, there goes another.
I think one of the realities that I think we understand now that maybe we didn't 15 or 20 years ago is a whole spectrum of decision science too that actually some work is being done here on campus around, is that humans don't conceptualize risk in the ways we think they do. And so engineers are data driven. We like data. We think decision makers are going to make risk decisions with data. And so if we put data about risk in front of them, they'll make smart risk decisions. If people's fear of flying is any example, safest way to fly or safest way to travel, but people still fear flying. So we really have to think about how people conceptualize risk, and in particularly low probability, high consequence risk events, and help shape decisions in ways they can understand.
I mean, I think that's absolutely fascinating. One of the things, I don't want to get too political here, but I want to say something a little controversial. Punting on fourth down is a horrible idea. If you look at the numbers, it really, really is, right? But it's about...
But it's everybody's
But everyone
playbook,
does
isn't
it because no one's going to get fired because they punted on fourth down, right? And so this is the reality of the world we live in, and we have to understand that humans make the decisions. One thing I've been thinking very deeply about recently, and I don't have an answer yet, but kind of ties into this, is we used to have very nice categories for critical, life critical, safety critical systems and non-safety critical systems, right? You can put the pacemaker is clearly critical. My kid's Xbox is clearly not critical, right? But now,
Depends on who you ask.
But I mean, 10 years ago, say, or whatever, 15, 20 years ago, right? But now these lines are blurring every single day. They're getting blurrier and blurrier. My sister-in-law is a type 1 diabetic. She has a diabetes pump that is a physical system that's in her body that has,
Connected to her phone.
connected to the cloud. And my brother can, from his phone, monitor her blood sugar and, help her manage her disease. But is this what part of this is a safety critical system? Is it the pump? Is it the app on my brother's phone? Is it, we have, the Volvo I know is I've been talking to some Volvo engineers lately, and they're doing a lot of this kind of stuff we're talking about, being agile and quick and, using continuous integration. And they've seen tons of great reductions in the integration time because they're getting to integrate a lot faster because they're using this. But, is this a critical system, right? What is the software doing in the car? Can you isolate it? These are challenging questions. It's only getting harder and harder and harder to answer this question of where does this system lie? And I don't think this is, and I think this is absolutely a DoD issue as well, that these systems are becoming very complicated, and it's becoming less and less clear that there is a critical system and a non-critical system. Everything is becoming, one massive interconnected world, and it just brings a whole new set of challenges. And
I think it's less easy for a consumer to make choices, right? I have a Wi-Fi enabled dryer. Why do I need a Wi-Fi enabled dryer? But I couldn't buy one that wasn't, right? So
Yeah.
that sort of context is very real. So would you join me in thanking these individuals for their expertise today? I really appreciate it. And thank you for your wonderful questions as well.